Dear students, wish you all a very happy and prosperous new year. Now let us discuss about numerical differentiation. You have already studied in the previous presentation detail about the polynomial and then all the Newton forward, Newton backward, and for unequal space data we have learned the Newton divided, Lagrange's interpolation, and now today we are going to discuss about this numerical differentiation. Then what do you mean by numerical differentiation? Just to look, it is the process of calculating the value of the derivative. What is the numerical differentiation? It is a process of calculating the value of derivative of a function at some assigned value of x, from the given set of values. So why we study here in numerical analysis? Because of this. If for the given set of values xi, yi, to compute, what is the purpose? To compute dy over dx. Okay. So we first replace the exact relation y is equal to fx by the best interpolating polynomial y is equal to phi x. Okay. So here, first of all, we have to replace this because there is no exact relation is given. Okay. Relation is given on the basis of certain data. Okay. So this is by the best interpolating polynomial y is equal to phi x, and then differentiate the latter as many times as we desire. If it is required the first derivative, then we can find the first derivative, second derivative, third derivative as desired into the problem. Okay. So now how we can find out the derivative by using the forward difference formula. Of course, we are talking about Newton's forward interpolation formula, which you know that y is equal to y naught plus p del y naught plus pp minus 1 by factorial 2 del square y naught, and so on. It is easy to see that we can very easily differentiate both sides with respect to p. We have, okay, the dy over dp. We can write this as del y naught plus 2p minus 1 by factorial 2 del square y naught plus 3p square minus 6p plus 2 by factorial 3 del cube y naught, and so on. Okay. So now, and here we know P is, what is P? P is x minus x naught by h. Therefore, dp by dx is 1 by h. Now, dy over dx, you know, we can write for the parametric coordinate system, dy over dx is dy over dp into dp by dx. So if you want to write dy over dx with the help of the previous result, then you can write here dp by dx multiplied dy over dp. Previously you have already calculated, multiplied by dp by dx. So this is 1 by h times this. 1 by h times this. This is the original formula for dy over dx as it was required into the problem. At x is equal to x naught, p is equal to 0. Hence putting p is equal to 0. Why? Just you look here. At x is equal to x naught, you put here, then you will get p is equal to 0. Then dy over dx at x naught, you will get this result 1 by h del y naught minus 1 by 2 del square y naught, and so on. Okay. Again, differentiating this equation with respect to x, we will get the second order. Second order you can find like this: d2y over dx square is d by dp of dy over dp into dp by dx. So in this way, you will get this result. This is important result: 1 by h, 2 by factorial 2 del square y naught plus 6p minus 6 by factorial 3 del cube y naught, and so on. Okay, into 1 by h. Okay, now the putting p is equal to 0 again, you will obtain this beautiful formula for second derivative d2y over dx square at x naught is equal to 1 by h square del square y naught minus del cube y naught, and so on as it is written. Okay. Now similarly you can find out the higher derivative del cube and del cube y over del x cube dx cube dq y over dx cube at x naught, you will get 1 by h cube del q y naught minus 3 by 2 del power 4 y naught, and so on. You have to verify manually by doing yourself. Okay. So here don't note only because at this level it is expected from every student you don't follow and write as it is. You do your own calculation. Okay. You do your own calculation, your own derivative, then you assume and correlate if this the result is same or not. So this is one way of to discuss about the numerical differentiation. But since we already know about the various operators, so with the help of operator also, you may find the same result. How? Just you look here. This is the second method. Otherwise, we know that 1 plus forward del is equal to E shift operator, and this is equal to E power HT. D is your differential operator. So from here, by these two relation, you can write down HT is equal to log of 1 plus del and 1 log of 1 plus x. You just expand this series, logarithmic series. So you will find del minus del square by 2 plus del q by 3 minus del power 4 by 4 and so on. And from here, just you can check from these two relations, d is equal to 1 by s del minus 1 by 2 del square plus 1 by 3 del q and so on. So very easily you find this derivative term. Okay, if you multiply by this is d operator means d over dx. If you multiply by y, then you will find dy over dx. This is very simply by using the operator. So this is the beautiful application of operator to find such the nice result. A connection of the operator, you can say. Then similarly, d square also you can write like this, and d cube also. Now applying the above identities to y naught, we will get, just you apply the y naught, then you will get this formula dy over dx at x naught is equal to 1 by s del y naught minus 1 by 2 del square y naught plus 1 by 3 del q y naught minus 1 by 4 del power 4 y del power 4 by 4 y naught and so on. You will get this result. Okay. Similarly, you can calculate and you will find d2i over dx square at x naught like this, and dqi over dxq at x naught like this is equal to 1 by h cube del cube y naught minus 3 by 2 del power 4 y naught. Please verify these results and you will get the same. So which are same as the previous equation number 2, 3 and 4 respectively. So you got, if you know the connection between the operator, then that is also a method to find the these results. Okay, the higher order derivative results, and which is absolutely the connection between forward and del operator. Now let us look the example. Okay, how the example and how many type of the problem it is asked into your major examination or minor any kind of examination, where as a curricula you are reading this title, this subject. So the following data gives the velocity of a particle. This is applied problem. Velocity of a particle for 20 seconds at an interval of 5 seconds. Then find the initial acceleration using the entire table. So this is the beautiful example where we compare our knowledge with the physical world. How you can apply into the physical world. So this is a real life physical world problem. Time in second it is given 0, 5, 10, 15, 20. Velocity in meter per second it is given 0, 3, 14, 69, and 28. The differential table, first of all you have to obtain the differential table. Okay, so you can obtain the differential table like this. Okay, this is time, this is velocity, this is del v, this is del square v, this is del q v, and this is del power 4 v. 0, 5, 10, 15, 20. Here 0, 3, 14, 69 to 28. It is given. Already it is given. Okay. So now with the help of this, you know the forward operator del v, you can find out 3. Here 14 minus 3 is 11. Okay. So 14 minus 3 is 11 here. Now here you can find out 69 minus 14. That is from here to here. You will find 55. And then from here to here, that is 159. Again, similarly, from here to here, you will find 8. And then from here to here, you will find 44. And then from here to here, you will find 104. And again, from here to here, just you go and you'll find del QV, third order, that is 36, and then 60. And from these two, you may write very easily, that is 24, that is del power 4 V. So in this way, you can continue an initial acceleration, that is dv by dt at t is equal to 0 is required. We use Newton forward formula, and dv by dt at t is equal to 0 parallel to your formula. So you can develop here the formula for this particular problem. 1 by h del v naught minus 1 by 2 del square v naught plus 1 by 3 del q v naught minus 1 by 4 del power 4 v naught. You can just restrict yourself here because this formula have up to the fourth order. Okay, so now put all the values from the previous table. So if you are putting all the values here, then just you will put and calculate. So you will find 1. The dv by dt is equal to 1. Hence the initial acceleration is 1 meter per second square. With the help of the data, you are able to calculate. Okay, so now in this way we have learned what is the numerical differentiation. Thank you very much. Stay safe. Thank you. Bye bye.